I just wanted to touch base with you before you got involved in doing the assignment with Coulomb's law problems. That Coulomb's law relates a couple of variables, and that is the electrical force to the charge, which is Q. And that says that that is a direct proportionality. As force gets bigger, charge gets bigger, or as charge gets bigger, that means the force gets bigger. And then it also relates the electric force proportionally to the inverse square of the distance between the two charges. And I know you read about this, and if you didn't, stop the video and go back and read about it first, because I'm going through this just really how to reason through some of the problems. The actual law looks like force is related to the product, those are Q's, the products of the charges when you multiply them together, and to the inverse of the distance between the charges squared. And that would not work out mathematically when we take our standard units of force in newtons, charge in coulombs, and there's two of them, so that would be squared over meters squared for distance. And so we have, that would not quite be true, so we introduce a constant of the value K is 9.0 times 10 to the 9th, and that unit comes out to be Newton meters squared per Coulomb squared, to get all of the make the multipliers, make the values come out to be equivalent to newtons. So with that in mind, we wind up with this equation, but you're going to encounter some problems that don't give you all the variables. You might be asked, find the new force if one of the charges is doubled, but you weren't told what the original charge was, you aren't told the distance. Well, it means those variables all stay the same. There's only one thing changing. So if force is normally Q1 times Q2 over R squared, and now suddenly we have this new force where Q1 times 2 times Q2 over the same distance squared. Well, what's different here? Well, we can see that we still have Q1 times Q2 and we still have R squared, but now we're just multiplying it by 2. Well, that new force, F2, is the same thing. Well, this is the exact same value that it used to be when we called it F1. So we're just going to say it's our old force, the first force, times 2. And so our answer is twice as big. What happens if both charges double? Well, we can reason through that this again the same way. We would say that F1 was still this, and now our new F2, both charges double, so that would be 2Q1 and 2Q2 over the same distance squared. And rearranging that, 2 times 2 is 4, and Q1, Q2 over R squared. Well, that's the same thing that F1 was, so F2 is now 4 times F1. What happens if the distance between things double? All right, we have our original force, F, Q1 times Q2 over the distance between them squared, and now our new F2 is Q1, Q2, they're still the same. What happens is we have 2 times R, the distance between them. We have twice as much. So mathematically, Q1 times Q2 over 4R squared. You have to treat the doubling of the distance, following order of operations. You need to double it first and then square that, because it's the actual number of meters between the two charges that is what is doubling. And so that means we have F2 is equal to, well, here is F1 and times 1/4. Or we could say F2 equals a quarter of what F1 used to be. When the distance gets bigger, the new force gets smaller. What happens if the charge is cut by 1/3? We still have F1 is Q1, Q2 over R squared. Miss Kavanaugh, where's the K? K's there. K can be there as part of this too. It's just a constant to make the math. And since we're not doing this and solving for an answer in newtons, but only in terms of another force that was not defined, we didn't really need to include it. Our F2 said one of the charges is cut by 1/3. Q1, Q2 will say stayed the same over R squared. We now have that F2 is 1/3 of what the original force used to be. That gives you an idea of how you can reason through those problems. Good luck on that, and I hope this short video helped. I'm aware that some of you are having email problems. Use Remind or direct messaging through Classroom, because I'm getting your emails, but I'm not able to respond to some of you that can send email to me because they bounce back. They're not coming back undeliverable to you. So I'm trying to reach you through Google Classroom, and I'm trying to reach you through Remind. Let everybody else know, and happy problem solving.